Previously on actual electrical content.
I'm in the garage. Pitch something up. Hey, cocksucker. If that's free, yeah, fuck it. Pop Fleming. Right, it's Monday morning. It is 12 o'clock. I've done my admin in the office and done it, well, not done it all, but I've got most of it done. It's time for some actual electrical content. Back on the barrel wash. Oh yeah, actual electrical content. Oh yeah, oh look at that. Oh, right up there. Oh, here, yeah. So my mate, whose brewery it belongs to, messaged me yesterday about something else. He goes, oh, I get on with the barrel wash. And I didn't have the heart to say, mate, it's still sat in the fucking workshop floor untouched. However, we're going to have a look at it today, so I don't know what's holding that down there. There's a single phase motor. I'm guessing that's a single phase motor. Yeah, that's going to be a single phase motor because it's got a 3-pin plug on the end. So we'll give that a check, get it clean, check the capacitor and whatnot, and maybe even fire that up and give it a little spin, see how it works. And the only other two electrical things that are sort of one that we need to be worrying ourselves with is this 3-phase element here. I think that's a 12 kilowatt over 3-phase wiring star. And then there's this. This is just a normal immersion heater stat. They've been using that to control the temperature previously, but I'm going to get rid of that and I'll go into that in a minute. But yeah, first of all, let's get this crappy old wiring out of here and the lid off that and see what's going off, and then we'll talk about how to test both of these things, and we'll test both of these things. So I'm starting off the, like I said, it's a 12 kilowatt, 415 volts, 3-phase heater. So they'll be wired in a star thing, and this here is an immersion heater stat. I don't trust that, but I am going to retain it as the final cutout. So I'm going to have 2 digital sensors on here that tell me the temperature to get it to 70. If I'll use this, I think, yeah, it's got a higher thing on. I'll use that so that if the temperature gets to 80, this will act as an emergency cutout as like a triple redundancy failsafe. So that's going back in. I'll just remove that, put it down there a second. The only problem is, because they've used a cable and they couldn't get 2 cables in, they've drilled the fucking lid like that, look. So I'm going to have to file that all down and bung that up and seal it up with some like mastic, because I'm not going to buy a new lid for it. It'd be expensive unless we've got a new lid. But yeah, that shouldn't have been done. That's a fucking bodge job I've got to deal with, so I'll deal with that next. But I'm just going to take all the wiring out of it and do some testing on it. Whenever I'm stripping stuff down as well, I always get a couple of buckets, yeah, and I just drop everything that comes off it, whether I need it or not. Unless it's absolute junk like this plastic, I chuck everything that comes off it in a bucket. So I've got one for the immersion, one for the motor, so I don't lose anything. Because if you start losing stuff, say it's got an imperial bolt on it, you can't find it, it's going to be a right shit house to find that. It's going to cost you hours of time when you're trying to turn the job around quickly. Well, I say turn around quickly, I'm too busy making fucking videos for Instagram here. But you know how it is. So there's the gubbins that came with it. Yeah, that'll do me. So now I've got somewhere to put my crap. A quick interjection as well. I'm 41 years old, yeah. I've been doing this like 20 fucking something stupid years now. And I bought something recently, 25 years, sad bastard. I bought these the other day. They're not screwdrivers, they're nut spinners, insulated nut spinners. Don't really need insulated ones, but I just bought them because like electricians should use insulated tools. I actually wanted the wearer ones. They look better, they look cooler, I think. But they were 80, 90 quid. I ordered them off a tool website, I won't name who it was. And then I waited days and days and days. It turned out they'd not processed my order because they'd fucked something up. So anyway, I cancelled it and got my money back. I hope I've got money back, I don't need to check, but I got these the Weir ones off eBay for 40 quid for the set, which I thought was a bit of a bargain. Hardly used, and I'll just tell you why I got them. Let me show you. Before I got these, I'd use a socket set, and I've got the feel for a socket set. I don't over-tighten my screws, but I appreciate with a lever, because obviously this hasn't got a lever, it's just got the axis of the nuts is on the same axis as the shaft, whereas if you had a lever on it, you can over-tighten it, because like ratchets, notoriously when socket sets became cheap in industry, instead of box spanners, people kept snapping the nuts off stuff because they had no idea that the lever is giving so much leverage. So they have got the touch. What you feel on this screwdriver is what the nut feels. What your nut feels. So anyway, they're just better for that. And when I'm doing this motors course, I was concerned people might start snapping my nuts off. Enough innuendos, but basically, yeah, I want to tell people on a motors course and in general life is that if you're not doing a submarine door, it should just be like this: 3 fingers, and when it's too tight, when your fingers slip, it's tight enough. So I bought these for a motors course. I just thought, try them out. I've never really had a need for one of these. I've used it fucking loads. I think they're great. I've used them loads. So, sorry from teaching you suck expert. Yeah, I've just acquired a set of these. I've 20 years and I do find them much more useful. Obviously, loads bulky in the socket set, but if I'm doing motors now or anything where I need to get in like this, I'm using these and I'm carrying these. So yeah, little top tip from an old boy there. I'm old now. So yeah, I'll undo this now. This is all junk, like, I mean, that's got DIY Dave written all over it, and it. Wrong size gland, wrong size cable, bit of tape wrapped around it, hanging out. It was like that and working. So I'm just going to disconnect it and I'll show you what's going off. I'll show you this immersion heater works in star configuration. Let me dig it all out with my nut spinner lock. Well, I'm not going to show you all, but that is just done. And then also, like your mum, yeah, it's held onto my nut. So it's come in, it's got the heater on, it's got the pump, and we're going to check they're okay. Yeah, I've took all the cabling off. Look, I've ditched that bit of cable, so I ain't never using it again. First of all, looking in there, yeah, and looking around the back of it, it looks to be in reasonably good condition. That's obviously copper or brass, and it's had water on it, that's why it's going blue, but obviously it's in water, that's fair enough. The casing seems alright, except for the big fucking hole in it. You see the die-cast aluminium, see how the paint's flaking off it? That's because it's been in contact with water and salt. So you know, if you have anything that's die-cast aluminium that comes into contact with water and salt, you know, like die-cast aluminium like you find in outdoor fuse boards, and salt like gets put on all the roads, and the fact that they're only driving in the cars. So that's what every single outdoor fuse board's going to look like eventually. It's going to start separating the paint layer from the material itself. So just be aware of that, kids. But yeah, other than that, it's all right. And then on the inside, look, let me change ways. There's some surface rusting. Not sure if it's surface rust or if it's rust that goes through, because those, I think that's just surface rust. Hopefully, I'm not sure what material they're made out of. They should be made out of a material that rusts. I don't know if that's just surface rust from bits or whatever, but hopefully that element's good. If not, that element has to be changed. Unfortunately, it came to with that element in, and we're hoping it's decent. And what we'll do now is we'll test it. Again, it looks okay, but that doesn't mean shit, does it? So let me show this element. What you'll see is there, look, you see here, this is one element. This is another one, look, looping over. And there's another one here. They're the L1, L2, three-phase of the elements, yeah? In the middle, there's a hollow copper tube. You know it's copper because there's some green going off there, look, that's so that the heat gets through it quickly. And that is where the thermostat goes. So in there, look, you'll see there's the common up neutrals in the star. L1, L2, L3, and then there's the copper tube where the thermostat goes down, so it reads the temperature good. So what we're going to do now is we'll leave that linking bar on, and we'll just test the elements to see if they're in good nick to earth and test the resistances. That's what the heater looks like when it's wired up. You've got the neutral at the star point, yeah, which is connected to the neutral leg, or one of the legs of all the elements, which are here. And then you've got one element to L1, and one element to L2, one element to L3. Obviously, with this being a 12 kilowatt, in total for a 4 kilowatt per thing. So I can do the maths and check the resistance out on them. So if they're 4 kilowatts, oh, let's do the maths. Hold on to your hats, because it's not very often you get maths on this channel, yeah. So when you're testing out an element, whatever kind of immersion element that is, you can Google the resistance you should get, yeah. But you can also do it with maths, which is loads easier. Now, if you're just dealing with 3 kilowatt immersion heaters, Google it, find out, whatever, yeah. But if you're dealing with like odd immersion heaters like this one is, because this is a 4 kilowatt three-phase one, well, it's 12 kilowatts, which means it's 4 kilowatt per phase. What if it was like a 15 kilowatt one? What would you Google then? It might not pop up. Don't know, Google it and try it. I'm not doing it for you. So what you need here is, you need your pickles in vinegar, your power over V times I, and then you need your Ohm's law, your V equals I over I, yeah? So what I've done is, let me just turn it around and show you this, because it's all backwards, isn't it, because it's a front-facing camera. I hope to God I've got this right, so I look like a right mong, but don't worry, someone will tell me, yeah? Pickles in vinegar, power equals current times voltage, yeah? So I've put my power, 4,000 watts, divided by 230, which is my voltage on each individual one, gives me 17.39. So it's 17.39 amps on each one of these is pulling on that. So on three-phase, 18 amps on that one, 18 amps on that one, 18 amps on that one, yeah? Then what I've done is I took the, so on that one, sorry, what I wanted was, I didn't have the amps. I needed the amps. And the reason I needed the amps was, one, so I know what to select my protective devices and my contacts and stuff and that at. But on this one, I don't know the resistance yet. That's the unknown figure. So that means it's voltage, 230, divided by current, 17.39, gives me 13.22222. So the resistance of those should be 13.22222. Let's find out. I've got this out. I've got a Mega, so I'm going to test it on the thing. So it's not a Mega, it's a Chevron R new insulation tester. Mega's a trade name, but you know how it is. It's a Mega. I've got it in the ohms. I've zeroed my leads out. So if I am not mistaken, honestly, the first time I've done this, I've got one of these leads, hang on. Put that first one on the star point, because I can do all them on that. And let's go on to the bottom one there. So I'm looking for 13.222. Oh! 14, that's right. I think my maths is right. Don't worry, someone tell me if I'm not. I'll take it off that one. I'll put it on my next one. Oops. Like that, look. 14. And the last one. 14. Hey! So the maths is right, I think. If I'm not correct, then I'll put an apology out. I think that's right. That's cool. So they are good. They're good, continuous, and work. However, do they go to earth? That's the main problem with them in. The problem is, there's no water in there, is there? But what I'll do is, if they pass the insulation resistance test now, I'll fill it with water tomorrow, let it soak, and then I'll do it watering just to check there's no problems with it. Because obviously, it's not a problem to change this afterwards, though. If it is, we can still use this marking. We can still use the lid, basically, but it might need, no, it might not. So I've set it up for insulation resistance. I've got it on 1,000 volts, because why not? Let's crank that bitch up. Press test. That's doing its thing. Pumping out some voltage DC. Do I let go? It's the first time I've used this. Oh no, yeah, there we go. The voltage has crashed out to 0.1 volts. I'm guessing that's because... There you go. How do I do this? Press and hold? Oh, there you go, look, yeah. It's fucking... It's nothing. There's nothing there, is that right? Yeah, that was right, look. It doesn't give you a value because it's shorted. When you press that lock and you wait while it does its thing... Yeah, it doesn't give you a value in kiloohms because there's no there, look. It's totally dead shorted as it is. So it's not giving me a value. I'm guessing to invite me to look at the screen and go, there's nothing there. Because if I take off this crocodile and put it on that wood and do it then, it's doing it. So it's got it to there, look. So it's saying, oh, because now that wood's damp. There's something on there. So yeah, it's saying... It's greater than, it's getting 450 volts during the test, and it's greater than 100 gigaohms, because this is a gigaohm one. My previous megas have only been, my previous insulation resistance testers have only been up to megaohms. This is gigaohm, so...
These go to 11.
And that's gone right across there. And let me just show you something quite nice that happened a minute ago as well. This is genuinely nice. I'm going to mark this as advertising because I'm basically advertising it now. I'm just using this, but I'm basically advertising, so I will mark it up now. I forgot, apologies. I've not tagged Chevron in it or like that, so I weren't generally trying to advertise, but it's getting that way. When you turn it off, it says it's off. Nice touch. When I turn it on, it kept saying battery, and I'm like, oh, fucking hell, the batteries are dead. And then I was like, oh, I'll keep using it till the batteries go flat. Then I realised, look, it's saying, no, I've done it too quick. Turn it off. Let it go off. This is a nice touch, honestly. It's saying the battery's at 90% and gives you a visual reading. That's cool as fuck. So I'm happy now that my batteries aren't flat. I'll just show that one more time. So I just think that's a really good feature. I've definitely marked as that now, aren't I? Watch. Battery 90%. There. Cool, eh? Apologies, I should have done this at the start. That meat was given to me for the purpose of me to use, yeah. It won't give me any indication I'd use on anything. However, I am using it. They gave me some time ago. I am sponsored by Chevron. They pay me money for my office for reading on this podcast. However, they don't have any control over my Instagram videos or my YouTube videos or even to the right to feature in this. It's just that I'm using this product now. So, fair play. Everything you've seen, beware, it is classed as advertising. And this is basically going to be very addy because I like this meter. So, yeah. Just for full disclosure, if this is on YouTube, I'll interject this at the start of what's just been seen. But yeah, just for fairness and transparency, this has basically turned to a bit of an advert now, but I'm just trying to demonstrate how to measure this. Okay? You okay about that, Eddie? Cheers. So basically, recap, I think we got to the point where I put this on here as a dead short, and we established that it just reads nothing because it's a fucking dead short. Nothing lights up on the screen, and it just... says nothing, look. The voltage is crashed. So, you know, it's just like, there's a dead short, basically, that is. Sorry about that light. There you go. If we take the crocodile clip off, so there's nothing there, fucking light needs getting rid of, and press it again, and then we're getting up to, like, That's the moisture on the pallet, I'm guessing that is. Because I've left it touching the brushes, touching the pallet lock. And it's picking that up. That's incredible. I'm not even setting this up. That looks like something I've set up. Let me just knock it off that thing. Come off there. And you're not touching the wood now. Well, fuck me. Aren't gig ohms mental? Look at that. That's gone loads higher. That means that brush conducts. Wow. I don't know if you're still here, but that went up to... It got to its voltage 1,000 volts and got 128.4 gig ohms just by a line on the pallet. I've put it on that concrete over there out of the way. Will it go higher than 128 gig ohm? Sorry if you're bored. I'm just amazed that that's picking up 190 gig ohms now. Over 200 gig ohms because I'm on 1,000 volts. That's fucking insane. I mean, just attach that back to that brush. Let's just attach that back to the bristles of that brush like it was. So that means there is some sort of measurable path to this. This meter can measure the path through that crocodile clip, through that brush, through the wood, up there and to there. By rise, it should be about 127 again, if it's doing it again. I've never had a gig ohm. I've never had a gig ohm one before.
These go to 11.
Do a thing then. Fucking hell, look. That's starting about the same place and that's rising to about the same thing. Yeah, it's consistent. Look, it's got to its maximum voltage and it's hanging around the 129 gig ohms figure, which is exactly how it was before. So there's some consistency there. That is amazing. I've never really delved this deep into the gig ohms area, but that is lingering around the 125, 135 area. It's full voltage. I'm cane the battery by holding it down, and that is measuring through that brush. Let's just prove that by knocking the brush off. Just knock the brush with the crocodile clip onto the floor, look, and it's fucking... It got knocked down again then, but it's going past, look. Although the crocodile clip's touching the floor, that's incredible. Yeah, it's just rising. I'm astounded, look. Anyway, this is boring now. Anyway, now I'm on one end of the... I know these are continuous through here, so I've just gone on the common up end, so I'm here. So then I'll mega them out to earth. Insulation resistance test to earth. 3.44 mega ohm. So yeah, it's not short, is it? Let's try on gig ohm. Try on that 1,101. See what we get. It's 1,000 now. Oh yeah, still 3.25 mega ohm. Well, there's not a short one, is there? So they're all right, I think. They're not contacting earth, basically. So as far as I can tell, they're good. But the true test comes when I put some water in there. But for the now, we'll work on the fact that they're going to heat up and be good. So yeah, that's how I test that. I've done all the maths, I've done the readings of 14 ohms. I've done the mega testing. Anything else you want to know, let me know now while I'm doing this, and I'll cover that as well. But obviously, we've done the visual inspection. I think we've got everything there, haven't we? I hope that's useful to you. Rather boringly, yeah, Chevron have sent me pels and analyzers and all that kind of stuff, and I've enjoyed playing with them. And I know what they do. I know they measure voltage. They analyse electricity and that, and they're all right. They're good stuff. But it's not. It's never astounded me like that Mega just does. That's the first gig ohm Mega I've ever really got to play with since college, and I'm just astounded that I've got a resistance reading between the crocodile clip line on the floor. That's proper interest in me, that is. God, I'm fucking boring, but yeah, I'm genuinely going to have a bigger play with that later because I'm so amazed that I was getting a consistently measurable reading through this plastic brush, which is a bit damp. That is interesting. That is very, very boring. I might do a whole video on insulation resistance now with that tester, because that's proper fucking baffled me. Anyway, now we're going to do this motor. So let's crack it off and do the inspection bit. So it's a single-phase motor, as I suspected. It's got a single-phase plug. There's a capacitor in there. Looks to be in decent condition. I want to take the motor out because there's obviously these unions here to get the motor out. I've had to take these off on previous brewery things to clean them out because they're full of gunk. And then what I've noticed is it doesn't seem to be fitted in any way to this. It feels solid as fuck, but as you can see, look. Oh, but that's flopped off there. I think that's meant to be more across. I think there's some bending been going off. That's clearly meant to be there. That'll need fixing down as far as I'm concerned to make it a bit better, but we can sort that out later. There's a data plate for it, but it's just a visual on that. I'm just going to squeeze 240 down. I'm not starting mega in a single phase motor with capacitors and stuff. I'll just pump some voltage into it and see if it fucking works. And hopefully we can seat it properly as well, because the seating's a bit shit. And we'll put 240 into it, see what happens. Fuck it. All hanging out, look. All bits of copper on show. On a 3-pin plug with no start. It's on a 3-pin plug with no motor protected devices, like it should do. So there's nothing to stop it overloading except the fuse in there, which is, I suppose, acceptable. It's not got a proper motor start-stop protection on it, but it's been pack tested. Fuck off. Right, let's plug it into it up, even though this plug's dog shit, look. Stand by. RCD protection in place, people. Sound swings and up. That'll do. Don't want it to drive too long. Get that out of the way. And the next thing I'll do with that is this. Because that SY is dodgy as fuck. So that's gone. Right, that can go in the bin. So I've recovered what I want of this now. And what I've got's working, so we'll leave it at that for the time being. We'll revert to a bit of design now. In other news then, it came to me lying down, the whole thing. I took that off, I've got that lid. I've got that back in, look, where it wants to be. I've just mocked up a plate here, because on this side of it, I want to have a power connection box, which will be the power for the 3-phase for this, and the single phase for that. And then next to it, I'm going to have a control, which will have 2 sets of terminals for the temperature probes. And that might possibly be it. There might be an emergency stop on the front, something like that, but that'll be about it. And then what I'm going to do is I'm going to get those boxes mounted, rewire everything, clean it, put it back together, do something about bolting this motor down, even if it's just a referencing bolt so it can't move. It's pretty secure on them. And then the other thing I'm going to do, which I'll move back and show you in another minute for that. Let me show you the other thing I'm going to do while it's here. This thing ain't new, but I think it's a little bit homemade. They've left this on. This, just out of interest, this is, you'll see it says, it's for laser, fibre and laser CO2. This paper, you can't cut this with a laser unless you've got this paper on it. I think it burns it. This is like a protection device for both the quality of the metal and to help the laser cutter work. You'll see it's not just normal plastic, like it's carbonated. It's got carbon in it. What I think is, it's pretty much, looking at that welding, it's semi-homemade. It's been knocked out of some little metal workshop. They're obviously having the laser cut, steel cut. They're press braking it. They're manking it together and producing what is a commercially acceptable piece of stuff. But obviously it's a little bit homemade junk. They're not being mass produced, basically. So they've never took the stuff off, which I'm going to do, because I'm going to insulate the entire thing. So I'm going to use some of that, part of the job of it being here, I'm going to Celotex it. I'm going to put some 70mm Celotex, which is like the stuff you see in walls, insulation walls, in here. One on the bottom, or where I can get on the bottom. I mean, that's not going to be the most easiest task to Celotex that. I'll bring it out here, and then I'll stand sides that go up to here, because this is going to have water in it at 70 degrees. That element is going to be burning 12 kilowatts of energy, yeah? And what we don't want is the water to heat up and just this to act as a giant radiator. So I'm going to insulate this, and I'll also make a lid for it that goes over the top so that they can put the lid on, so it'll try and fill these gaps the best it can, keep most drafts from coming in, so it ain't got a big open top. Slide over these, maybe even like a duvet type thing like you get around immersion heater, so that when they turn it on, the heat that's being created stays in there. Also, there's no need for these gaps. If these gaps were closed off permanently and the barrel went there, that would be better. So we'll have a look at that, but we don't want to give the heat away.
2 weeks later.
Back on the barrel wash then. So I've done all the maths. I know what needs to go off, and what I want to do today is I want to get that pump wired down to a box, which is going to go down there. I've got to sort the mess that's been made out of this out. It's got a 25mm gland here. Obviously that's pointing in the wrong direction. I'd rather that weren't pointing up so I didn't get moisture and stuff in. This hole down here has been bored out. That would have been threaded, but they bored it out because the last person has not been sparking, they bodged it. So that's causing me grief, so I need to fill that in now. And a normal blank for conduit's not long enough, so I need to sort that out. Get these cables down here. We need to get a box mounted here, because we're going to have the pump to the box, the heater to the box, the total overheat probe, like it's got too hot, final cut off down to the box, then 2 temperature probes are going to sit on it underneath, probably down to the box that's going to go here. So it's not going to be very interesting. It's just normal electrical work, more contract the control side, but I'll show you how I get on with that. It's a mate's rate job, this is, as well, so I'm doing it for my mate for free now. Most of the stuff I've got kicking around in here in the fucking dump that's the workshop, look. Making it honest, it's still a dump, but I've got a lot of shit kicking around from a lot of years of work, so the problem is this turns in, and when it stops, it stops. You can't just put it where you want it, so I've got to come out the top. Also, some other little things are, this is going to have some caustic situation in it, some caustic liquid that's hot. There shouldn't be a lot of water on the outside, but it's going to get dripped on, so I need to make allowances for that. And also, I need to use fittings that don't get knackered when it gets the cleaning solution on it. So there's loads of stupid things I've got to consider for this. Here's a top little clean up tip, yeah. I save all my dog food tins in tins like this, yeah. Then when I'm cleaning up the stuff that looks like this, or I acquire leftovers from a job, I lay them all out here, look, so I've got thousands of fucking bean tins everywhere. And then my first port of call for any fittings is I go into the tins to find it, which reduces the amount of shit in the tins. Then when I get the trays out, like this one, look, and I see there's some 20mm blanks there, I go over to the tins, there's those 20mm blanks, and I stick them back in there. That tin's now empty, and while I'm in there, look, there's a 25mm doocer. That lives in there, and I just keep putting it back as I go. Then when these tins are empty, I get a new tin, and I start filling it with more shit, and that's how I keep all my shit. And then when I go to a job, and I want to take a handful of things, I get a tin and put it in a plastic tray. I take a few of what I need and a few spares in the tin. I go to site, use it, and when it comes back, it's in a tin, and it ends up back in the box. So for a few bean tins in a plastic box, maybe like that, or like the tray ones, save myself a lot of money losing bits of shit. I weren't going to use this box, but I was going to put an adapt box here with the lid upwards, not this box, but the two boxes have got the same size, but one's a proper box, and it's going to block the fan, which I don't want to do. So now I'm going to put it on here like that and have all the controls locally in there and the connections. That's just a Garrow box I'd lying around there. Eventually come out the skip. And to do it, I've cut a bit of Paxlin, which I'm going to now bolt onto there, look like that. Paxlin's a real art form to work with. It's rock hard, and it's just a cut. It bluntens all your tools. I'd like to know the history of it, actually, if anyone knows, please tell me. And as if cutting Paxlin and blunting my tools weren't enough, now I'm going to drill the Paxlin with a drill, which will foot a drill up, into this stainless steel, which is rock hard, and I'll foot a drill up, so I can tap this Paxlin into here with some stainless steel screws. So yeah, loving wrecking all my tools today. That's it, it's finished. Well, the skid's finished anyway, so let's have a look at what we're going to control. So you can see, like, it's not the neatest job, yeah. It's second hand anyway, and I'm doing it for mates rates out of gear I've got lying about. But under here, you'll see there's a temperature sensor on that one there, and a temperature sensor over on that one there. That's not because I want to measure each part, that's because it just gives a convenient place to attach the sensor on different sides of the tank. They go down that Copex there. You've got a single phase pump there, the immersion heater here, and here's what we've got to control. The pump connections are on this black box here. There's a temporary plug on that so they can use it, or there's going to be. Then in here we've got the immersion heater, the fail-safe stat, and the two temperature probes. So yeah, that's what we're going to control. I've got it working. We've done all the maths, the skid's ready. Now all we've got to do is construct the panel. So yeah, there it is. I reckon that's it for part 2. The skid's done. We've done the testing. We've checked all the stuff on here. So now we need to automate the panel, which is coming next. But the guy who's got this wants it back so he can use it for cold washing. So I've got the skid sorted out ASAP. Go and put a supply in and get it back to him. So yes, hang on for part 3 where we're going to actually make it all work together and do all the commissioning and stuff. So who knows how long that'll be. See you later.